That's my new theme song.
Yeah, exactly. You need, what I'm saying?
Mario Kart.
Z-Tunes, okay.
Okay, we got guys that are starting to get into refrigeration. I know a lot of you guys are on different things. And I had someone say, hey, there's no video on how to use the torches or whatever, so I decided I do have a video that talks about sealed system tools, but it was more like I had pictures and I was just talking about what they are and so forth. So I decided I'm going to make videos that are going to be like, these are the tools, but also this is how you use the tools or what we use them for. So today we're going to start off the sealed system one. It's going to be multiple part videos. I'm going to put that in the members section. Some will be posted free on our regular YouTube channel. This one will go on regular YouTube. We have torches that are used to do different jobs. A lot of people like the oxyacetylene torch, which is what we have here, and we call it oxyacetylene because we use two separate tanks. One tank here, the green one is the oxygen, and the smaller red one is the acetylene. And when you have the two tanks, it's the same as our turbo torch, and I'll show you that in a minute. But there are advantages to both and disadvantages to both. This one here, a lot of people like it because you can make a much smaller flame and you can braze with it, where a turbo torch is a lot bigger, louder flame, but it's a lot easier for lighting and so forth. So I'm going to demonstrate how to light these, how they work, and then we'll do another video another day about the different types of brazing: copper to copper, copper to steel, copper to aluminum, aluminum to aluminum, and how we use different torches for it. But this is a very hot torch. Remember I said there's advantages and disadvantages. And one of the disadvantages of these torches, even though you can make a lot smaller flame, which is good, like when you're down underneath the refrigerator in a compressor area, you don't want a real big flame because there's a lot of plastic down there, there's wires down there and everything else. An excessive flame could melt or damage other components if you're not careful inside the unit. So, turbo torch, this is just straight acetylene, like the oxyacetylene torch that I showed you. Here we got a turbo torch set up. This is a smaller tank like the one that I just showed you. We got a brand new tank here. And all it is just one hose and so forth. So let's just talk about it. So this is straight acetylene, acetylene dissolved. And in order to use gases, even like when we have like a propane tank, like a barbecue grill, gas stoves, gas dryers, we have to have something called a regulator. So this is a turbo torch, and I'll go ahead and write this down. We got to have a regulator. Regulator is this piece right here, which is attached to the top of your tank. This is the regulator for a turbo torch here. So this attaches to the tank. The regulator has two functions. Let me just attach it on there. Now, this is regular, what we call right-hand thread, which is like regular righty-loosey, lefty-loosey, righty-tighty. But on this one, acetylene is left-hand thread, where oxygen is right-hand thread. We'll look at that in a moment. So, never use a pair of, channel lock or regular pliers when doing any type of gas or plumbing fittings. Even if you're doing like underneath your sink, yes, you can use pliers to tighten it, but this is brass and it's very soft and you'll chew and damage up your tools here. Always use a open end or an adjustable wrench that'll fit your regulator and just tighten it up. It wasn't tight yet. First, tighten it by hand until it stops turning. And you also want to set your regulator with your hose up. And this one's not set up like that. And the reason why, you want to be able to see your regulator. I'm going to tighten this up here. that has something on the face. Now this hose is starting to go bad, but this regulator has an adjustment on the back here. And I'll show you guys how we adjust this. This adjusts the flame size. Most torches on turbo, when I use it, I have it at the maximum flame. One of the reasons why I call it turbo, unlike the oxygen acetylene where we mix oxygen and acetylene together into one hose or tip coming out, this is just straight acetylene. You need oxygen for it to burn properly. So they have openings in the tip of your torch here which pull air in and mix air with the acetylene in the tip and come out the end. Now inside the tip, they have like these little swirling blades, and what that's supposed to do is help create a mixture of the oxygen acetylene coming out. If you have a problem with the tip where it's not burning properly, but you have brand new tank and everything else, could be that a lot of times people use it at a real low flame and the flame burns back inside and damages, or there's not enough oxygen and it builds up this black soot, which is when oxygen is depraved of your flame, it creates this black soot. When you're lighting an oxyacetylene torch, one of the disadvantages, I said that we have advantages, disadvantage, is that when you light them, if you don't give it enough oxygen, the flame is very yellow and this black soot's flowing through the air. This is like oil, liquid oil. And if it gets on the customer's furniture, carpet, curtains, or anything else, you can't just wipe it right off, and it doesn't really clean too well. Just imagine taking tar or oil and rubbing it on your clothing and expect it to come out in the washing machine. It's not going to come out. So one of the purposes of this regulator is that when you get a tank, the tank is under pressure. It's a lot higher pressure than your torch is going to use. Okay, so what the regulator will do is control the pressure of the tank to a pressure that we can use on this one. Now, unlike the oxyacetylene, we actually set the pressures to a specific number. We'll talk about that. But the turbo is just on or off. So one thing to do is we open up this tank here, and we should always check for leaks. I'm just going to do another quick tighten on the wrench on the tank, just real quick. And turn it on. You can hear the gas coming out. Going to use a striker. Striker has something here called a flint. I'm going to show you guys, I'm going to put this on the camera here, this flint is removable. You can unscrew the flint from the striker, and they sell replaceable flints, and I'll show you what they look like. And you can screw on a new flint, so you're not buying the whole striker every time this flint wears out. The little piece here on the end is the flint tip, and you can see the differences between the two. And this is what they look like. This is the part that's the actual striking part that creates the sparks that light the gas. This is the old one. The new one, you can see how worn out it is in the size, okay? So we can replace these flints, and we can always buy a pack of replacement flints. It's a good recommendation to keep it. A lot of people say, I just use a lighter. That's not safe, because you've got a little device with gas in it. If your lighter malfunctions, puts too much gas, and you're trying to light that, or your flame on your torch could also cause that lighter in your hand to explode or whatever. With a striker, your hand's further away from the flame than when a lighter, you're right there next to the flame with your hand. It's not safe. So you could buy, this comes with like a pack, a bunch of them. We're down to the last flint. We probably need to get some more. But when they wear out, you can always replace it. I've seen a lot of people have these, and this thing's completely worn out. It's just on the metal part that screws on. They're still trying to use the striker. Now, let me just screw this back on. When you use a striker, there's a proper way and an improper way to hold it. I see a lot of people, when they use a striker, they hold it like this, and they create the little sparks. Okay? That works. But when you're holding it like this, you're pushing this up and away from the part that it rubs against to make the or the sparks to light it. Hold it with your hand across the top of it So you're pushing it down into the part. Do you see how much more sparks that I'm getting when I'm doing that? That's like that, but if I hold it like this, I'm not creating the sparks that I want. So always hold it with your hand over top, whether it's right hand or left hand. This is not good because, well, I can still push down a little bit, but this is a left hand and I'm not lefty, so I'm gonna do it with the right hand like this, okay? And light it like that. So that's a striker. That's used to light the gas. So when we light a turbo torch, this has a little scale on the front of it, and that scale just shows you how much gas you have in the tank. When you open it up, and I'll just put on video, I know y'all can't see it, but when you open it up, this shows me here that this tank is not even completely full. And the funny thing is that tank was a brand new tank. I just opened it up today for the first time. So to light it, well, let's talk about safety first. First of all, having the torch tank up here, that's not safe. Falls off, it's going to hurt somebody. Make sure that your hoses are not tangled up like this before you use it. Untangle them. I always like to put it up against a table or something that it's not right in the middle of your work area where someone's going to kick or knock it over while you're working. In the shop here, we usually put it right up against a table leg so that it's got something just to lean against, so it's less chance. But if you have it all tangled up like this and you're working, it's easy for you to pull this tank over. Okay, we have a welding instructor here who was doing a welding job, and some sparks flew off and landed on his hose and melted through the hose. Now gas is coming out the hose, and that could be very dangerous, especially with those sparks that were flying there. So again, don't put the torch right next to your work area. Put it sort of behind you with the hose coming across, and just have this in the area that you're working. So when we open the gas up, now, if I adjust the regulator, I can make it smaller, but look, by making it smaller, I made the gas pressure less. It's not pulling in enough oxygen. Notice how we're getting a lot of a yellow flame. We don't really want that yellow flame. We want it more blue than we want yellow. Okay? I go like this. This is how I do. Now, a turbo torch is not as hot as an oxyacetylene torch. So it takes a few more seconds to braze. I can braze a line just as fast as anybody with an oxyacetylene can. The advantage I have is when I light it, I just turn it on and I'm ready to braze. With the oxyacetylene, one of the biggest problems I have is because we have two different gases and two different tanks being mixed into one, we have two adjustment valves on our torch that will control the gas pressure coming from each one and the mixture of each one. If we have too much acetylene, it's too yellow. If we have too much oxygen, the flame will pop like it's not lighting. So when you light a torch, you have to crack them both open. And if you hear it pop, what do? I turn what on? No, if I hear it pop, I give it more acetylene. Popping is the oxygen, but there's not enough gas mixed with the oxygen to stay lit. Okay? If I see a bright yellow flame, what do I gotta do? Add more oxygen.
Oh, oxygen.
Remember, yellow is lack of oxygen in the flame. So I can pull down like an air hose and pull this tip right off. That we have 3 different size tips. Okay, we have a small one, medium, and large. Now the small one is smaller, so if I'm going to braze with the smaller tip, it's going to take longer to heat up the pipe. But if these bigger tips are too big in the work area that I want, I can't use a smaller tip. I just pull it out, open it up, and now a smaller flame. Okay, just on or off. So I can just pull this one out. I I can go with the big boy here. Depending on the size tube and the area that I'm working, I can change sizes. Now, one last thing. This is another tip. It's a self-lighting tip. Now, we've had a problem with a few of these, so let's see how good this one is. No, this one's not working. Someone probably wasted that one. But you can buy these where you don't need to use a striker. You just press this button. Now, we do have one in the cabinet, but it was missing this little tip on the end, but it has a striker here. And so it's self-lighting, which this makes it really nice, not having to have a separate striker and flint, but you always keep this one as a backup. Okay? So all you do is you just turn this on. You don't need to turn it much, just about a turn and a half. This one here, when we adjust the regulator, when I go in, like tighten it down, it's actually more gas. When I come out, it's less gas, okay? So it's opposite like a water hose, where you open it up, you think it's more water. Well, on this one, to get more gas pressure, you have to push up on the regulator to allow more gas out. So I said the regulator controls the pressure from here to here. So what happens is that if this tank was inside an air-conditioned house, or let's say you had it in your truck and then you brought it in an air-conditioned house, depending on how much heat is applied to this tank is how much pressure this is under. The regulator will open and close but maintain a constant flow of pressure coming out. It's the same thing like when we have a gas stove or a gas dryer. Those appliances have regulators on them, so that like if you had a gas stove with 4 burners on it, just imagine, think of a burner as like a sprinkler of a hose. I turn on one, the flame is going to come out. Well, if I had 2 sprinklers on the same hose, and I turn on the second one, a lot of people think they would both drop down. But what a regulator does is a regulator will open up and allow more gas so that the flames aren't going like this. Imagine cooking, like frying potatoes or french fries or something in a frying pan, and you turned off the burner next to it and the flame got bigger on your frying pan. You don't want the flame to get bigger or smaller while you're cooking. You want it to maintain a certain height. So that's one of the other purposes of the regulator. One is to make sure that the full pressure of the tank isn't coming out, but during the use or heat or whatever's applied, your tank pressure will go up and down. The regulator is going to maintain the flow coming out for use. Okay? So this is turbo. We're not going to go through the actual brazing today. I do have a video on brazing, but I'm going to go over the different types of brazing probably tomorrow, where I'm going to set up and show you regular copper to copper, copper to steel, and the tools we need to cut, bend, swedge, and then actually braze them together. Any questions on this torch? Yes?
Not on the torch, but I do have an ignorant question.
Okay, it's fine.
What's brazing?
Brazing is when we're applying or attaching 2 tubes together, almost like welding. The difference is brazing is a lower temperature than welding. And we use a filler metal, or a metal that when we join 2 pipes together, we use a metal we call a brazing rod, which is one of these here. This one is called Sil Floss 15. It was what I was going to show after the other torch. But this is Sil Floss 15. Sil means silver. The 15 means 15% of this stick is actual pure silver. The higher content of silver that's in your filler metals for brazing, the less heat we have to apply to braze. We have here, it looks like a capillary tube, and I brought a capillary tube just to show you that a lot of people look at this and don't realize that this is actual solder or brazing rod, okay? This comes in a roll instead of a stick. This is 45% silver. Now with the cost of gold and silver right now, this stuff's expensive. It is easier to flow, so if you're doing a compressor job and you're doing a line all the way in there, you probably want to use the 45 because it takes less heat and it'll be easier for you to braze than this rod here, which is going to take more heat to stick. A lot of times we use the 45 when we're brazing copper to steel, because when we're brazing dissimilar metals, steel needs more heat than copper for the solder to stick to it. You may be brazing, and you can use 15, don't get me wrong. I've done complete compressor jobs with a 15, no problem. But if your steel pipe is not hot enough, your solder will melt onto the pipe from the heat of your flame and just fall right off the pipe, because the pipe is not hot enough for it to adhere to it. Okay, when we braze, and again, I'm going to get into that when we demonstrate brazing, a lot of people are applying the heat to the solder and melting it onto the pipe. When the pipe's not hot enough, the solder's not doing its job. The idea is to get the pipe hot enough so when I touch the stick to the actual pipe, the heat of the pipe is causing the solder to flow, not the heat of the flame causing the solder to flow. Okay? So I'll get a little bit more into this. I did have this stuff here. I just wanted to first go over the different torches, but good question.
One more question.
Sure.
So it's 15% silver and 45% silver?
Yes.
So the rest of what is it composed of? Like if it's 15%, it's
I don't know all the materials that make up the rods. I do know that the number is the percentage of silver, which is what's going to make it easier to flow when we're brazing. What the actual base metals are that go with it, I don't know. Honestly, I've been doing this for 40 years and never even inquired. I just said, 15, 45, okay, we'll use that one. So that was a turbo torch. And here's a regulator. Let me move this out of the way for a minute so you guys can see that. And this is just a regulator. You see it says acetylene on here. This gauge and this gauge are two different things. This part is connecting to the tank of your gas. So this is your tank. And it connects here. Okay? This is telling me the pressure that's in my tank. We use nitrogen as well, and it has a regulator on it like this. A nitrogen tank fully charged from the gas company that delivers it is about 2,000 to 3,000 psi. If you were to open up this tank without this regulator, it's very dangerous because of the excessive pressure that's coming out of the tank. Okay? So the acetylene has to be controlled. This here is the flow pressure that's coming out to my torch. Okay? So when we're setting these torches, we have to set both the oxygen and acetylene one time when we do our torches and set up. So if we look here, each tank has its own regulator. So I open them up. I don't need to open them 10 times. You know, guys get in the habit of opening up every tank and they turn it until the tank, or even the refrigerant gauges, they turn it until it doesn't have any more turn. Just crack it 1 or 2 turns. Turning it 10 more times is not going to be like a water hose. If I turn it 3 more times, I'm going to get more pressure coming out. It's on or off, really. So these are nice because they actually have handles on them, or dials that you can open them. But some of them, they don't have the dial. It's just a square tip on the end. Let me see if I can find you a picture. Let me get my mouse here. I think I spelled that wrong, but it'll straighten it out for me. Okay. Let's see if I can find one that I'm looking for. So let's look at this tank right here. If you look at this tank in this picture, and I'll move the torch. Right here at the top, there's no dial for you to open it. It's just a square tube. Do not use pliers. Don't use vice grips, don't use channel locks. Use an actual key that they have. I'm not gonna do it while I'm recording, I'll show you guys in a minute. We do have just a little tiny piece of metal that has a square hole on it. And a lot of times they have a chain, and they'll leave that chain attached to your torches. Attached to your torches so you don't lose it. It's not here. But we also have one in the cabinet that's ratcheting. It's like a box wrench, ratcheting box wrench, but it has square holes. Refrigeration techs use it to open what we call king valves. Those are like the AC unit you have outside your house where the two lines come in and out. A lot of them have a place for you to close off the outside unit from the inside unit, like if you're doing a evaporator clean out or something like that. You want to trap all the freon outside. We use a wrench to tighten that down, similar to the one we have on top of here. But this one's nice. It came with the dials on there. So again, the first two gauges are going to tell us how much gas we have in the tank. The other two are going to tell us the pressure coming out of the tank here. And we're going to set the acetylene, I'm just going to put the A for acetylene about 5 psi, and the oxygen at 15. So we can adjust these two dials here to adjust the pressure. We have to adjust them what we call the flow rate pressure. Now you all might want to come up closer so you can see how I do the adjustments on this. I'll do the oxygen one first. Excuse me. So it's a little hard to see, these hoses are getting old, but one hose is red and one is green. This one's the red one, this one's the green one, so I'm doing the oxygen. So if you can see now, I have, this one should be open. And it has very little pressure in there, so someone did not close this all the way and my oxygen tank is almost empty. So that's not gonna be able to probably light this. This should show me the pressure of the tank, this one here, and then this one should be set to about 15. And I didn't even know it. I just pulled this off the shelf. These were refilled not too long ago. People are not shutting the tanks off when we're not using them. And then the hoses will slightly leak out. And if you leave it on your truck like that and you got a job to do, before you leave your shop, either the night before or the next day, you know you got a compressor job. Check your tanks. You don't want to be in a customer's house and your tanks are almost empty and you're in the middle of a job. And now you have no gas. Now you have to leave to go get gas, and hopefully it's within a closed space. Let's see if the acetylene does have some gas, but it's low too. This one, if you look, the pressure here is at about 10 psi, which is the flow pressure on the tank. I'm gonna open up the acetylene one, and it drops, right? What's it drop to? I can't see it from there.
Almost like 0.
Almost to 0. So we can adjust it. So both of these tanks are empty. That's nice. So we'll have to get gas and replace them so we can light them, and I'll show you how to light them. Hopefully tomorrow. Get these tanks out, put them in my truck, and I'll stop by Johnstone and pick up some gas tomorrow. So you want to set these from 5 to 15. So I'm going to demonstrate how to light these tomorrow. And when the gas comes out, you need to crack both of these at the same time. Just crack it, and then you'll light it. If it's popping, I go here and I look at the acetylene, I give it a little more acetylene. If it's too yellow, I want to cut the acetylene down. Okay, so we'll demonstrate that tomorrow. I do want you to notice, do you see some difference between these two nuts?
One is right and one is left, it's like opposite.
Well, what do you see visually?
One scored in the middle.
And that's the left-hand thread. That's going to be your acetylene. That's how you know. If it don't have the notches on the nut, it's not acetylene. Okay, it's the oxygen. All right, so we'll demonstrate how to adjust this and light this tomorrow. So what I'll do is I'll re-edit this video a little bit and mix them both together and fix them. Any questions on this? Because I'm not going to be able to show this to you. Gene, look in here and see if I have two small tanks like this. Can't believe I'm out of both oxygen and acetylene, because we refill these all the time, and every time I see them, they're empty. And when's the last time you seen someone do sealed system working?
But I think that one been low for a while. Cause I know they used it a couple times.
replaced them.
On those refrigerating was working on those refrigerators. You replaced it, okay?
No, I replaced these not
Since
too
then,
long
okay,
ago.
okay.
And so let's just talk about the solder. So here we got 15%. Here we got 45%. And I just recently did a video on this one here. This is called a braze. And I will teach you a little bit on how to actually attach two pieces of aluminum or copper to aluminum using braze.
Aluminum brace?
Braze.
Brace, okay.
And this is for brazing aluminum, so very, very low flame. Almost a pocket lighter would almost work on this, okay? Anything hotter, if you use a torch like that turbo, when I lit it, it just burned a hole right through the tubing. Now when you are brazing, this is called flux. It's a white paste stuck together, because that's what happens. It gets on the threads, and then someone didn't even put the cap on right, and you can see all the flux on the thread, so now I can't even take it off without a pair of pliers to break it loose. This stuff will get a little dry. Just add a couple of drops of water and mix it up till it becomes like consistency of real thick toothpaste, thicker than regular toothpaste. And you just brush it on your pipes as you go to connect your pipes together. So if we're going to connect these two pipes together like this, we use a torch, we braze them together. On copper to copper, you don't really need flux, but you have to prepare your tubing. This tubing's dirty. You put your hands on it. Have you ever touched a window and left fingerprints on the window from like the oil in your skin? You don't want that all over your tubing. The cleaner your tubing is, the less chance you're gonna have of leaks or something like that. Just like any job, preparation, a little bit extra time in preparation is gonna save you a lot of time in trying to fix something later that didn't go right because you didn't prepare it right, okay? So when we're doing copper to copper, we don't really need flux. You can use flux on everything if you want. You can even buy brazing rods with flux already on the rod. The braze does have flux mixed in with the rod, so I do not need it for this. But if I'm going copper to steel, I'm going to flux together every joint that I'm gonna do copper to steel. So when we cut tubing, and we go ahead and we'll talk about tubing preparation and everything and the tools for tubing. When we cut tubing, we wanna sand both fittings that are together. We wanna make sure that when we're sanding, that our debris from the sanding material does not go into our system. Remember, this is a refrigerant system. We don't want anything but refrigerant. We don't want air, water, ducts. We don't want anything in there. So when we go ahead and we put this together, we're gonna sand it first. Sand this here like a brand new penny, because this is copper, so it should look like a brand new penny. A lot of times people have a bad habit, I do too sometimes, is they sand it.
No.
I'm blowing on it. I put moisture from my mouth on it and moisture inside my fitting. Don't want to do that. Or they sand it and then they take their hand and they do this to clean it. But like I said, if you touch the window, you got oil. We don't want oil on our tubing when we're going to braze. We're going to cause leaks. So keep a nice clean rag. Hey, if you want to sand it, take your shirt. Do this if you really feel comfortable that you have to rub it. Don't put your hands on it. Okay? So that's how we're going to do that. This was a striker, and these are the different types of brazes. So I'm going to have to get gas to show you. I didn't know we were out of gas. I know we refilled them not too long ago. We haven't had anybody do a sealed system job in a long time, especially with those torches. So I don't know why I'm out of gas. Any questions on it?
Where do you get the gas from?
Johnstone Supply is right here behind the racetrack, and actually, you know the off lease?
Yes.
It's right behind off lease, those big warehouses, right behind it's the corner one. You do have to get an account with them. You can pay by credit card or put a card on file if you want, but you have a business, you just fill out the application with your licensed business and also tell them you're a student of the school. They'll let you fill out a business application. They do not sell to the public. Now, there are other places you can get gas. You'd have to research it. You can get it directly from like Tri Gas or other companies that all they do is sell gas. But there's other places like Refus Center. There's AAA Supply by the Burger King off of 135th. They sell gas and they sell AC equipment and supplies. You got Johnstone Supply. You have Refus Center. There's quite a few places that would sell you this as well. Or welding supply places would also have these tanks, because you could actually use them to weld. It's a lot higher heat, but you could do something called gas welding. Any other questions? No? So then I'll see if I can get the gas, and then we can do some demonstrations of the different types of welding and brazing, and we'll put those videos together as one video. I'll cut and edit this one out a little bit and add whatever video I do. I will tomorrow at 6:15 do another one, and we'll demonstrate. I'll talk about cutting, preparing your tubing. We'll do copper to copper, copper to steel. We'll do copper to aluminum and aluminum to aluminum. So I'll show you all those different braze joints. And we'll also do both torches and show you how to do it. When I'm done with my lectures, I'll give everybody an opportunity to light the torch and do one braze joint if they want. I do have to pick up some more solder though. We don't have a lot of solder sticks lying around, so I do need to make a supply run with Johnstone. Any other questions? No, I'm sorry it was short because I didn't have the gas, or otherwise I'd be lighting that and demonstrating that torch to you as well.